lesson 2.7, parent functions and transformations. So let's go to this worksheet. Identify the type of function represented by each graph. So I just want to know what type of function it is. Like this right here, that's a linear function. You can also know it as a constant function, that also counts. This one right here is a parabola, right, or quadratic. Notice that's curving. This is an absolute value. Right, you can tell by the V-shaped. And then this is a linear, right? This is a constant. It's probably the better answer for this one because it's a straight line going across. Horizontal lines are constants. And then the slanted ones are linear. Linear is still true, the first one though, because it just means highest power is 1. It's a line, right? That's a line and that's a line. So they're both linear. Describe translation and then graph the function, right? So the key here is inside opposite, outside follow. And when I say that, I also expect you to know that opposite inside is the x values, outside is the y values. So look at this first one here, right? This is on the outside of x squared. Inside would look like this. Right, that'll be the inside. So this is on the outside. That means it affects the y values. Right, and then all I mean by that, so y means, so here's my x, and here's my y. Right, so y moves, y moves up and down. So this is outside follow, so it means plus 4, so we're going to go up 4. So all we got to do is start at 4, and then graph a parabola. Again, it's just a sketch, the parabola part is just the sketch part. So look at that. Next one, also on the outside, right? It's outside the absolute value. So it's outside follows, we're going to do -3. And outside also means y, right? So y is up and down, because this is my y graph, up and down. So we're going to follow, down 3. Right there-ish. So, and then we describe the parabola. The absolute value. So it's going to be. So there we go. Not my best V. Next one's on the inside. You can tell it's inside the parentheses there, or the absolute values. So this is inside. Inside is the x, so we're going to move left and right. The key thing is you do the opposite. It's kind of like you're solving a problem. If I was solving this, I have to subtract the x over. So it's a -6. So we're going to go left 6. So like right here, here, then we just draw the absolute value again. So there we go. So let's talk about the reflection. So, right, when it's on the outside, so you can see right here with the first two. I mean with these two, but even better. This is on the inside, this is on the outside. So right here, that's the outside. There's no parentheses, so it's considered the outside. So if it's on the outside, I call that a y-axis. A vertical flip. That's what I call it. So this is a vertical flip. So normally a parabola looks like this. We're going to flip it vertical, up and down. So it's going to look like this. Some people call it x-axis flip. For me, it's a little confusing because I think about outside as y, so I want you to think up and down. So you're going to flip it up and down. But you do flip it across the x-axis, hence x-axis flip. The next one's on the inside, so it's going to be a little tricky. So it is on the inside, so it's horizontal, flip. Because inside's x, so you're going to flip it left and right. So what does the absolute value graph look like? Normally it looks like this, like a V. Well, when you flip it left and right, nothing kind of changes. You just flip this here and that there. So it's the exact same graph. But that is a horizontal flip. You flip it left and right. Or some people call it the y-axis flip because you flip it across the y-axis. This one's on the outside. So outside's y, so you move up and down to vertical flip. Normal absolute value graph looks like this. That's not my best work. And then we're going to flip it up and down. So like this. Stretches and shrinks. Okay. So, as we talked in the video, this is 4 is on the outside. So you follow what it says. So if you multiply something by 4, it gets bigger. So it's a stretch. It's on the outside, so it's a vertical. So it's a vertical stretch of 4. It's a stretch. Okay, so let's talk about what a normal absolute value graph looks like. It looks kind of like this. with absolute values, it works the best. Think about it, it's like slope. Because that's all it is. The 4 there is like a slope. So you can go over 1 and up 4. We'll do the same thing on the other side. Over 1, up 4. So it's like this. You can see it's a vertical stretch. It stretches vertically. Now it's a lot skinnier vertically. That's all that is. It's like a slope. Stretch or shrink. Well, notice that's on the inside. So normally we multiply by 2, it gets bigger, but it's on the inside. So the inside's opposite. It actually shrinks horizontally. So horizontal shrink. So if you want a thing like this, that's all it does. It's a line. You pull it out. You're like, hey, it's a vertical stretch. Yes, but they're the same thing. They are. In this case, they are. Well, they are. So if we started 0, think about it's like slope. Over 1, up 2. Over 1, up 2. You get this. So you can see it did like this guy here, right? It vertically stretch. But when you do that, you also horizontally shrink. Same thing here. Normally it looks like this. Probably show the normal one. 1, 1, 1, 1. And you horizontally shrunk. Okay, the next one. 1/2 x squared. Now it's on the outside. Outside you follow. So you multiply 1/2, you get smaller. You multiply 1/2. So it's a shrink. It's a vertical shrink. Now, how does the parabola look like? Kind of like this. Kind of like that. Now the 1/2 doesn't work. It's not perfect if you do it like depends on the slope. It kind of works on the first time, but it's not perfect. So if you think about it, like it goes over 2, sorry, and not 1. Over 2 and not 1. Now that's not gonna be a perfect answer because it is not a line, but it does give you a good idea of what it should look like. Right, so it's a vertical shrink. If you see like it got wider, it's because you shrunk it down, so it's wider on the sides. So that's how it works. All you have to worry about is it on inside, is it outside? Okay, so it's on the outside, treat it like a slope. Write the equation for each. So this first one here, what's going on? It's a parabola, so x squared. Did it move left or right? Up or down, left or right? It moved right 2. So remember, when it moves left and right, that's on the inside. It's an x-axis thing. It's horizontal. It's a horizontal shift, so it's on the inside. So it should look like this: x parentheses squared, and inside is the opposite, so -2. That'll give me that graph, right? Inside opposite. So it moves left and right, so it's on the inside because the inside is the x values, and you do the opposite, so x -2. Look at the next one. It's an absolute value. And what happened? It moved down 1, 2, 3, 4. So it went down 4. Remember, so that's on the outside, you can just follow it. So like this. So it's on the outside, you just follow what it says. Next one, it moved left 3. So it's absolute value, but it went to the left 3. So remember, inside opposite, so +3, like that. The one over here just went up 1. So it's a parabola that went up 1. Remember, if it goes up, that's outside. Move up and down to the outside, so this plus a +1 on the outside. Now I'm going to do 2 translations. Okay, so over here, inside, right, inside opposite, so left 3. Outside follows, we're going to go down 4. So, start at 0, 0. Let's go left 3, then down 4. Or if you want to go opposite, go down 4, then left 3. Same spot, doesn't matter. Then we're going to do the absolute value. Now there's no stretch or shrink, so let's use 1, 1. Just like that. Next one is a parabola, so inside opposite, right? So we're going to go +1 or right 1. Outside follow, up 2. So start at 0, 0. Then we're going to go, from there we're going to go right 1 and up 2. Draw a parabola. Right, this is a sketch for the parabolas for now. They all have a slope of 1 for basic ones. This one looks funky. You want to think about just like an x graph, like a linear, right? So if I was doing this, that's on the outside, so I'll go down 3. And there's no left or right, but there is a slope of 2. So that's like a vertical stretch of 2. So let's try that. So I'm going to go down 3. Then I'll do a vertical stretch of 2. So I'm going to go up 2 over 1. And that's the correct answer. But again, if I see a linear line, I'm not thinking that. What I'm thinking is normal, right? Y-intercept -3, slope is 2. So 2/1. Same graph, right? Two ways to think about it, the same graph. Okay, almost in here. So this one, it's a little different. Instead of giving you like a normal graph, I just give you a graph already. So here's a graph, a random graph. They want you to do this thing to it. So treat the exact same way. What does a 2 do? It's on the inside, so you do the opposite. You go left 2. Inside affects the left and right. What's on the outside? Down 1. Right? So -1, outside y follow, so you just follow what it says, you go down 1. So we're gonna take all these graphs here. You can see the normal ones right here. And all we're gonna do is move them left 2 and down 1. So this point becomes here. So I have this guy move it left 2, down 1. So the same thing for this point, we're gonna move it left 2 and down 1. If I was right here, left 2, down 1. And the same thing for the third point. Move that left 2 and then down 1. So that point right here, left 2, down 1. Now you have the exact same graph, just moved over left, the whole graph shifted over left 2 and down 1. Okay, last question. Kenji launched a toy rocket from ground level. The height ht of Kenji's rocket after t seconds is shown in blue. So that's the blue one. Emily believed that her rocket could fly higher and longer than Kenji's. The flight of Emily's rocket is shown in red, so it's Emily's. Identify the type of function shown. That's a parabola. How much longer did Kenji's rocket did Emily's rocket stay in the air? So the ground's right here, right? So it looks like the seconds, about 2 seconds. 1.5 seconds, about 2. Right, so this is the time in the air. So this was, Kenji's was about a little bit more than 8 seconds in the air, and Emily's was like right at 10 seconds. So it's about 2 seconds. How much higher did Kenji's rocket, did Emily's rocket go? So Kenji stopped at 100. Emily's went all the way to like 125. So about, we'll say just 20 feet higher. The type of transformation between the two graphs. So if I want to make the blue graph look like the red graph, what do I have to do? I have to go up 20, and then I would also have to go, I think their centers are fine. Probably have to go up 20, right? That's like the right center. I'll just say x plus 20. I think that's all you need to do. I think the rest of it's fine. Like you don't need to move it right because then you're off center. It'll just be up 20. So you need to move it up 20. Vertical, probably more correctly, vertical shift of 20 up, just like that. That's the lesson.